Hello class, this is the introduction video for your groundwater lab. So the lab manual, this page that you're looking at here, should be page 119 from your lab manual. And in this particular lab, you are going to go through all of it. I'm going to help you throughout all of it. So the way I recommend that you do this lab on your own is by listening to this video as you do the lab. That's going to be the easiest way to get along throughout it. So let's get started. So I'm not going to read this for you. You should check this part out though, just to give you a refresher of whatever we saw in lecture, or you heard in lecture, I should say. Okay, so we're going to start with part A. So part A is called well log interpretation. And so I'm going to read this. So well logs are records that drillers fill out every time a well is drilled. In Idaho, these well logs are filed with the state and are an important part of understanding water rates. The screened section of a well is a portion of the well casing that is perforated and allows water to flow into the well. So here he's referring to figure 2. This would be this location right here. So that's what's perforated, and that's where water can actually go in through and eventually be pumped upwards. So ideally, the only location that water will enter a well is in the screened section. So if you don't have any holes or anything like that in your well, then ideally that's the only place that you'll receive the water from. Okay, so the following pages are published logs for 2 wells near CWI in the academic building. So, and those you will see in page 121 and 122. So use the reported data to draw a cross-section of the aquifer in the figure on the next page. So I'm not going to make you do that. I did it for you, but I am going to take you through how I did it. So through the steps of how it is done based on those lithology reports. So let's see. So bedrock geology is listed as item 13 of the well log. And then casing and screen information is in item 9, and then the water level is listed as item 12 of that well log report. So you can follow along with me as I do this. I'm also going to post them on the document that you're going to see, so it's not going to be too hard, but you can follow along with me as well. Okay, so that's what we're going to do first. Then we're going to answer these questions based on that. Okay, so this analysis, questions, and instructions. So here he is telling us how it is that we're going to go ahead and do this cross-section. So use the well logs to create the geological cross-section of the area where these wells were drilled. Correlate units over distance if you can, meaning you should probably match one location or one unit, one rock unit, to another one in the other location if you can, meaning if they exist, both of them. And if they're not like way too crazy. So correlate units over distance if you can. Keep in mind that some may pinch out, meaning they might appear in one of the locations but not in the other. So they might eventually pinch out before they get to this location. Okay, and you'll see that. And then it says use hash marks to indicate which section of the well is screened, as you'll see. Okay. First, fill the geology in the area between 2 wells, then add the groundwater and screen information after your geology is finished, and make sure to fill in the legend at the bottom of the diagram. So here I'm going to show you step by step sort of how I did what I did. Give me 1 second. Alright, so here are the 2 different well logs. Again, the first one, which is labeled CWI001, and his name is Farm A. That's going to be the first one corresponding to the most west side of your diagram on page 123. And then this one, which is labeled Geology 101, CWI003, that is Farm B, which is on the eastmost side of the figure on page 123. Okay? So I'm going to show you the important parts that he talked about. So the part 13 or item 13, that is the lithologic log, the one that we're going to use to correlate the units in each of the logs. That's what we're going to use. Item 12 is right here. That's a static water and well test. So here it's going to tell us where they found water first and where the water is static meaning where it continues to be constant. Again, same thing, 12 here, 13 here. And then item 9, which is right here, is going to tell us about the perforation and the screening, as you'll see later on a little bit bigger. So again, item 9 here or item 9 here. They're both the same type of well logs, which makes it easier. A lot of times they're made by different companies and they can be much different. But overall, they have the same information throughout, or they should. Okay. So here are items 12 and 13 zoomed in for you to see a little bit better. So let me move me. So as you're seeing, things like the static water level, farm A is going to be 85, farm B is going to be 70, and then you can see the lithology is a lot better as well with this figure. So first thing that we do is we look at the image that we have, that is the diagram that he gives us, where we're going to make the cross section. So the first thing that we need to do is fill out a legend, right? So the legend is going to be this bottom part telling us what colors we're going to pick for each of these lithologies or the water pattern itself. So I did that, and those are the colors that I chose. Okay, so now we're going to start filling out the actual cross section. And ideally you would do it by looking at the lithologies per each well site and just marking the levels at which those lithologies fall, and then later on correlating. But to make this a little bit faster and easier for you, I went ahead and just did one lithology at a time, correlated throughout the space, throughout the cross section. So, okay, so again, the first lithology that we have from the surface downwards is going to be brown sand on both of those wells, so that's convenient. So the brown sand on farm A goes from 0 to 30 feet below, and then farm B from 0 to 35 feet below. So that looks something like this. Farm A to 30 feet below, farm B to 35, and we were able to correlate it, meaning carry it across that distance and match it kind of like that. Next we have gravel, which goes from 30 to 85 in the farm A, and then we have gravel in two places on farm B. So we have it from 35 to 55, and then we have it from 60 to 95. In between the 55 and 60, there is another formation or lithology that is coarse sand with clay lenses. So how is that going to look? We don't know yet. What I'm going to go ahead and do is draw the gravel going all the way from 35 to 95 without any interruptions, and then I'll go ahead and input this coarse sand with clay lenses later on. So when I draw that huge gravel layer, I'm going to be able to correlate it to this other gravel on farm A. Okay, so that's what I did. Again, it goes to 85 on farm A, and it goes to only 55, and then picks up at 60, all the way to 95 on farm B. Okay, now it's time to take care of that coarse sand with clay lenses. So I know that it appears on farm B, but it doesn't appear on farm A. So that means that it probably pinches out. It is there in farm B, right? And then as it's moving towards farm A, it eventually pinches out before it reaches that farm. So it would look something like this, where it goes from 55 depth in farm B to 60 farm B, but it doesn't appear at all on farm A, so it pinches out somewhere along the way. Maybe I made the pinch out too far, maybe I made it too close. We don't know. If we had another well here in the middle or somewhere closer to either farm, we would be able to pinpoint how far that layer, that lithology actually goes, but we don't. So we're kind of free to choose how far we put it. Okay, so after I have that gravel, I believe at the bottom, we have coarse sand on farm A, and we also have coarse sand on farm B. Coarse sand on farm A goes from 85 to 100. On farm B, it goes from 95 to 115. So we display that way. Okay, good. After that, we have gravel with sand lenses in both of them. in farm A, it's 20 feet thick. However, in farm B, it's only 10 feet thick. So it's going to even them out a little bit more, as you'll see. Okay, so that looks a little bit more even throughout the two locations now. Then after we have the gravel with sand lenses, we have some black sand. The black sand is a little bit thicker quite thicker in farm B than in farm A. Here it's only 10 feet thick. Here it's 20 feet thick. So it's going to uneven them again. Okay, and we can correlate it. And then below the black sand, we have some blue clay on both of them. The blue clay only goes for 5 feet, which is how much more there is to the depth of, 15 feet, how much more there is to the depth of that well. And then here it goes for 10 feet, which is how much more there was to the well in the first place. So it ends up looking something like this. So once we have filled out those lithologies, which we did, now we have to take care of knowing where the screen section of the wells are, as well as knowing what the static water level is, meaning the constant water that we're going to find at depth. So for those things, we need, again, the item 9, which is where the screen section portions can be found, as well as item 12. So on item 9, we know that for farm A, the screen section goes from 90 feet below until 145, so meaning until the end of the well depth. So it's screened for 55 feet. On farm B, the screen section goes from 70 feet to 155, so also to the end of the well. So a lot bigger portion that is screened on farm B. And then we know that for farm A, the static water level, meaning the amount or where they found within the well that the water was abundant and was constant below, was at 85 feet. They did find some at 75 feet, but it wasn't constant. It was encountered, sure, but it wasn't saturated below that. It was only saturated after 85 feet or below 85 feet. For farm B, the first water encounter was at 65 feet, but again, that was just the first encounter. Where they saw that it was abundant and saturated below was below 70 feet in that well. So when we add those things, maybe, we have the screen sections. I mark them with this kind of texture type for either one of the wells. And then the water said that it went from 70, or it was static water level from 70 and below on the farm B, and it was static from 85 and below on farm A. And I'm saying that it's covering all of these layers. So there's a reason that I didn't say that it covered the blue clay, and that is shown here below. So here you can see that on the lithology, on the item 13 of either log, they also told you whether they encountered water or not at each of those lithologies. So that's what I did. So I said, okay, they found water in the coarse sand, in the gravel with sand lenses, and in the black sand for farm A. So here is the coarse sand, gravel with sand lenses, and black sand. Good, that makes sense. Not in the blue clay, however. No water. Okay, and they found water for farm B on gravel, right? Coarse sand, gravel with sand lenses, and black sand, but not the blue clay. So here the water doesn't go below the blue clay, but it goes above those other 4 formations. Again, it doesn't go above 70 because that's where it pretty much stops being continuous. It stops being saturated there. Okay, so that's pretty much the resulting graph that you are to work with for the following questions. Okay, so one thing to pay attention to is that these two farms are 3 miles apart. You'll use that for one of the questions. And again, if you need to refer back to this, make sure that you do.